captain of a ship, and in front of you is the ship's wheel. To turn it, you need both hands and you apply a force here and here. Notice that while one force faces up, another force faces down. By applying these two forces, we can turn this wheel, in this case, counterclockwise. This moment we create is called a couple moment. In 2D problems, all we need is the perpendicular distance from one force to the other. Even if we move this force to this point or this point, it won't make a difference, because what determines the couple moment is the perpendicular distance between them. This is also why a couple moment is called a free vector. So in scalar problems, we can find the moment by multiplying the force by the perpendicular distance. When it comes to a vector formulation, we take the cross product between a position vector and the force. Imagine a pipe system like this, and we have a couple force applied at these locations. When we find the couple moment, the position vector can be directed from any point on the line of action of one force to any point on the line of action of the other force. So for example, here we can use a position vector from A to B to find the couple moment. One thing you have to keep in mind is that since we chose a position vector going from A to B, we have to ignore the force at A. That's because at point A, force 1 can't create a moment about point A. Instead, we find the couple moment by assuming that the pipe turns about point A. If you had a position vector from B to A, then we would ignore the force at B instead. This will become much clearer when we look at the last two examples. So without further ado, let's get started. Let's take a look at this question where we need to find the couple moment produced by two forces. The distance between the two forces is 0.3 meters, so all we need to do is multiply that by the force. We will assume clockwise movement to be positive, and that's our answer. Let's take a look at this question where we need to figure out the magnitude of force F so that the resultant couple moment is 400 Newton meters clockwise. So what we need to do is add up all the couple moments created by each of the forces and equal it to 400. First, let's figure out the length of the triangle. Using trigonometry, you will find that each side of the triangle is 0.653 meters. So let's write our equation and we will assume clockwise to be positive. We see that both the 250 Newton force and the unknown force will create a clockwise rotation, while the 600 Newton force will create a counterclockwise rotation. The distance between the 250 Newton force is 1 meter, and the distances between each of the other forces are 0.653 meters. Let's solve for F, and that's our answer. Let's take a look at this problem where we have two wrenches applying a force and we need to figure out the couple moment created. So a moment can be found using this equation, which means what we need is a position vector from points A to B, since that's the distance between the two forces. We also need to express the 125 Newton force in Cartesian form. Since our position vector goes from points A to B, the moment of the force at point A is 0, so we ignore it. The force at B is straight upwards, so it'll just have a positive k component. Now that we have a position vector and a force, we can take the cross product. The question also asks for the magnitude of this moment. Those are our answers. Let's take a look at one last example where we have to express the resultant moment created by four forces affecting the pipes. So the way to solve a problem like this is to figure out the couple moment created by each of the pairs of forces. Let's look at upwards forces first. To find the couple moment, we need a position vector from A to B or B to A. I'm going to pick A to B. To get that, we first need to figure out the location of point B. Using trigonometry, the y component is 0.4 cosine 30 degrees and the z component is 0.4 sine 30 degrees. The x component is already given, which is 0.35 meters. Let's write down the locations of points A and C as well. Note that the difference between points B and C is only in the x direction. Now a position vector from A to B. Since our position vector starts at A, we ignore the force at A. So we consider the other force, which is straight upwards in the z-axis. So we can now take the cross product. Let's look at the other couple force now. For this, we can use the same position vector as before, because the line of action of force C crosses the position vector. But I will use a position vector from C to A to show that it's also possible to get the answer this way as well. You can also use a position vector from A to C. Since we chose a position vector going from C to A, we ignore the force at C and consider the force at A. Now we take the cross product. The last step is to find the resultant moment, so all we do is add these together. Remember, we add I components to I components, J components to J components, and K components to K components. That should cover the types of problems you will face when it comes to couple moments. I hope this video helped, and if it did, please consider sharing it with your friends and classmates. They too might find it helpful. Thanks for watching and best of luck with your studies.